For the application, let's start with the first problem. A small high school surveyed 52 of its seniors about their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, if we pick student at random, we can place them into one of four events. M being male, C going to college, F female, and not going to college. For number one, give the values of the probability of a random student for each of the following. I've already completed the first one. P of n meaning probability that the student is a male. So our sample space is out of the 52 students that were polled, and there are a total of 30 students that were male. Whether they were going to college or not going to college, 30 were male. P of F means the probability that this is going to be a female. I have 52 again for my sample space. And in this case, female, I have a total of 22. I'm going to leave it like such. Moving on to C. Probability of C. C meaning going to college. Again, the sample space is 52. Those that are going to college, there's a total of 29. The probability of N, meaning not going to college, out of my sample space of 52, not going to college, there are 23. Now that I've finished that, I'm going to go to more specific. 2, what is the probability that a person picked at random would be a female who is going to college? Again, what is the probability that a person picked at random would be a female and they are going to go to college? So I have my sample space of 52, and I'm looking at female and going to college. That's an intersection or an overlap. So if I come over here, female and going to college intersect right here at 13. There are 13 students that are female and are also going to college out of the total 52. So my final answer is 13 out of 52. Go down here to 3. What is the probability that a person picked at random would be a female or someone going to college? This is a little different. This is a union. When I have an or, that's going to be a female or going to college. So female, there are a total of 22 females. Plus going to college, there are a total of 29 students that are going to college. Minus, if I take a look again, the column for female and the row for going to college, I counted this 13 twice. So I need to subtract it because I cannot count it twice. And this is the formula we have, which is the probability of A plus the probability of B minus the intersection of A and B. Oops. So that, I want to separate that, sorry. There we go. We are still over 52. And our numerator is 22 plus 29 minus 13. That is 38. And that is our final answer. So we've down here to 4 and 5. There's a dash because they're completely separate questions. So 4, consider the sample space for the rolling of a single fair die. Again, the S is the sample space. 1, 2, 3, 4, 5, 6. That's what we could get. A, what is the probability of rolling an odd number and a prime number? So that's the intersection or the overlap between them. Rolling an odd and a prime. So my sample space, there's a total of 6 numbers that we could roll. And I want to look for the intersection. So if I'm looking for how many are odd, I'm going to color code that for us so that I can make it a little bit easier to see. So I'm going to do red for odd. So odd, I've got 1, 3, and 5. Okay. And then a prime number. I'm going to do a prime number with blue. Okay, remember a prime number, if you're not sure and you click this link, hopefully already, a prime number is a number that only has a factor of 1 and itself. So just to clarify, 1 is not a prime number. 2 is the greatest prime number. So 2 is a prime number. That's going to be blue because it's just divisible by 1 and 2. 3 is also a prime number. Now that was already highlighted as 3, so I'm actually going to make that purple because isn't red and blue purple anyway, to show that overlap. 4 is not prime. 5 is prime, and it also already was red, so that's now going to become purple. 6 is not prime. So now what is the probability of both of these happening? That's the overlap, which I already color-coded them as purple. There are 2 outcomes that fall into each of these. So that will be 2/6. I am not going to reduce it. I'm going to leave it as 2/6 because I want you to be able to see what my outcomes were or number of outcomes, and the number in my sample space. Okay, let's go down to B. What is the probability of rolling an even number and a number greater than 3? So let's do this again. There are 6 total outcomes we're working with in our sample space. I'm going to do color coding. Let's see now. I'm going to switch it black to black so we can start all over again. An even number, that's going to be red, so 2 is even, 4 is even, and 6 is even. And a number greater than 3. Make that one blue. 3 is equal to 3, not greater than, so I'm not going to highlight that one. 4 is greater than 3, but 4 was already highlighted as red, so now with blue it's going to become purple. 5 is greater than 3. That's blue. 6 was already highlighted as well, so that now becomes purple. And so again, I have 2 that are overlap. 4 and 6 are both even numbers and greater than 3. That is 2 out of 6. Our last question for 5, Red Hook High School students has 480 freshmen. Of those freshmen, 333 take algebra, 306 take biology, and 188 take both algebra and biology. Create a 2A frequency table and determine which of the following represents the number of freshmen who take at least one of these classes. All right, so I'm going to insert my table. On the side, I'll do algebra, no algebra, biology, no biology. I need one more cell on each. I have to have my totals. Okay, so now let's go ahead and fill them in. So 480 freshmen is how many that they're surveying. So that's going to be my total down here on the bottom right, 480. Okay, 333 take algebra. So my total for algebra is 333. So while I'm here, I'm going to subtract that from 480. And I get a total of 147 for the total of no algebra. Okay, 306 take biology. So biology total is 306. Again, while I'm here, let me just fill this in. 480 minus 306. That's going to be 174. And then the last piece of information, 188 take both algebra and biology. Algebra and biology overlap right here. This is 188. And I can use this to fill out the rest now. So I'm going to go down. 188 and something add to 306. So let me subtract those. 306 minus 188. I get 118. I'm going to keep going across. 118 and something go to 147. So 147 minus 118 is 29. Let's go up. Something plus 29 is going to add to 174, so I'm going to subtract those. 174 minus 29 is 145. And let's just double check across here. Is 145 plus 188? Yes, it's 333, so this is correct. All right, so I've made my table. Now I need to answer the question. Determine which of the following represents the number of freshmen who take at least one of these 2 classes. at least one of these two classes. Now, I just want to clarify, this is not a probability question. They want to know the number of, so that's why there are no fractions here, okay? So what is the number that take at least one of these two? So that means they're going to take either algebra or they're going to take algebra and biology, right? So if I take a look here, so because I have this table already made, I can go ahead and find the individual amounts. So I'm looking at algebra. There's going to be a total of 333 students that are taking algebra. And then no algebra. I just want to clarify, I'm not going to do this no algebra, no biology. Because if it's no algebra and no biology, then they don't fall into taking at least one of these two classes. So I'm taking the algebra students, which are 333, and I'm going to add in those who are not taking algebra, but they are taking biology. I'm going to add those up. So I'm going to add this cell up, and this cell up. That gets me a total of 451. Now your other option, if we want to see the fact that if they're taking at least one of these two classes, another way to look at that is saying that we are taking some class, we're not taking no classes, right? Which is the aspect of a complement. So I also could take my entire 480 students, and I could have just subtracted the students that weren't taking either of these classes. That also gets me 451. Just want to remind you, this is the idea of a complement, which sometimes can be faster.